Now that we have identified all these different relationships and these different patterns in the footprint matrix, we can now discuss how we build the process model from this. You see here on this slide a summary of all the relationships that we identified. They build the backbone of the process model that we are going to construct. By considering first the XOR patterns, we build up the model and we step by step add those activities that are required for connecting the disconnected pieces. Here in our example, we get exactly the process model to introduce this example. In this way, the alpha algorithm helps us to construct a process model which we then can use in order to understand the process in a more visual way. This is very helpful with huge amount of event data, since we get a visual model which we can nicely use to communicate and discuss the process. There are also some limitations that we have to take into account with the alpha algorithm. First, when we use the alpha algorithm, we need to make sure that the log data is complete in terms of the behavior that is possible according to the process. You remember we identified all these direct successor relationships. Only those direct successor relationships can be used for constructing the model that are really being shown in the logs. So we need to make sure that the logs actually capture all those behaviors that are allowed. Furthermore, we need to understand that we only can reconstruct the original process model as we have it done now for this example, if the original process model is structured. We have seen a few cases of process models that are more complicated and that do not nicely follow an AND split being followed by an AND join, an XOR split being nicely followed by an XOR join. Once the process models are more complicated and do not follow such a structured design, it is not guaranteed that we get exactly the model that we had originally. As a third point, we also need to consider the case that there are certain tricky bits and pieces with loops. Not all new loops can be nicely constructed from the logs. The alpha algorithm requires that the length of the loop is at least 3, which means when we have activities A, B, and C in the loop, this would be okay for the alpha algorithm to see that there's some repeating behavior around it. Once these loops are shorter and we have activities AB, 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 or we have sequences like C, 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 C multiple times, this would be a problem for the alpha algorithm to rediscover. The final point of limitation with the alpha algorithm is that it is not very robust. We have seen and emphasized that the alpha algorithm considers as input the unique set of traces. This means the alpha algorithm does not consider and take into account how often a certain sequence is appearing. In many cases, this is very important, since there may be noise in the log, and with noise, we actually do want to have some mechanisms of filtering and abstracting. The alpha algorithm does not provide any means for doing that. So therefore, we will as a next step consider techniques where we make use of the frequency that is associated with observing a certain behavioral pattern.